Welcome everyone to episode 18 of the Exoskeletons and Wearable Robotics podcast with me, Bobby Marino from the Exoskeleton Report, Dr. Tom Sugar, Wearable Robotics Association, and our guest today is Arun Jayaraman. Thank you so much for joining us. First off, we have no new patrons as of this recording, which is a perfect opportunity to mention our current VIP tier supporters, Volker Bartenbach, Rita Vasquez Torres, Min Mar, and our corporate level sponsors, Humotech, Oxivo, and HeroWare. Arun, thank you for joining us today. For everyone, Arun has a master's in physical therapy and a PhD in rehabilitation science, and he has been with the Shirley Ryan's AbilityLab in Chicago for the past 17 years. And for the purposes of this podcast, to the best of my knowledge, there is no other person on this planet who has tested and validated more medical exoskeletons and rehabilitation or robotic devices. So to say that we are thrilled to have Arun on the podcast would be a major understatement. Hi, Arun. Thank you for joining us.
Thank you, Dobby. Thank you, Tom, for having me on. It's exciting to talk to you both today.
So we're excited too, for sure. These days, people move and change careers and jobs and employers all the time. So for you to be 17 years at Shirley Ryan AbilityLab, that must be a really special place. Can you tell us more about it and what it is?
I came into the Shirley Ryan AbilityLab, which is the Department of Physical Medicine and Rehabilitation for Northwestern University. So I'm a professor at Northwestern, but I started as a postdoc. And frankly, as much as it's odd to say, you get kind of attracted to the place really easily because it is a perfect combination where you have bioengineers and rehabilitation personnel all working together. Historically, if you look at the field, there is kind of a dispersion where engineers work in a silo, clinicians work in a silo, and there's not a simple merger. The greatest advantage of the Shirley Ryan AbilityLab, which used to be called the Rehabilitation Institute of Chicago when I started, is where bioengineering and clinicians merge. And we all cohabitate. So when you cohabitate, then you get discussions of, oh, I have this great robot, or I have this idea of this neuromodulation device, or I'm building this, and what does a patient need? So what takes normally decades, we were able to merge those ideas much faster so that there is a more easier transition for clinical utility and commercialization of technologies. And interestingly, once you're there, you kind of not only drink the Kool-Aid, but you kind of swim in the Kool-Aid. So it's very hard to leave the place. And so, plus, I'm also a little old school that way. I'm dedicated to my organization and I want to make sure that the place is successful, whatever. And so, whatever my time is, you couldn't be in a nicer place of good people and hardworking people with a mission. The mission and vision is critical for an organization, and this place has a great mission.
And what is the mission there?
To simplify it, it is to help people with disabilities have a better quality of life, to improve the lives of people with disabilities. And that is why we even changed the name to AbilityLab, because disability has a negative connotation. And just because you're injured or you get older or you have other issues doesn't mean you're disabled. We just have to enhance your ability to get better. So that's why we renamed ourselves. The word lab means we're also doing research. So AbilityLab is to enhance human ability rather than say you're disabled and we have to fix you and something's wrong.
Thanks for emphasizing that, because I feel that's where I'm not sure if we always get the message across that this is not technology first or technology for the sake of technology. It is for the betterment of humanity, for what I like to call ushering a physical revolution.
So can you just give us a little bit of background of some of the systems or things you're working on? Meaning, like, I think of myself more as a lower limb, leg type person, but I think at your lab, you'd probably be, doing everything, like shoulders, arms, hips, knees, ankles. So, but can you just give us a sense of some of the the bigger goals, bigger projects, and then maybe we can dive in later.
Yeah. I know this is related to exoskeleton reports, but just to give you a larger perspective of what I do is I have 4 different roles. From the academic side, from the university, obviously, university-related teaching, student mentoring, that is one role. My own lab is called the Max Nader Lab for Rehabilitation Technologies and Outcomes Research. Max Nader is the former founder or owner of Autobach, who is the world's largest producer of prosthetics, orthotics, and other rehabilitation technologies based in Germany and in Austria. So they wanted a neutral site or a lab to do clinical research on prosthetics and orthotics and robotics work. So I run the Max Nader Lab. That is one role. I also run the Technology Innovation Hub for the hospital, which is for technologies outside of prosthetics, orthotics, and robotics. If you wanted to work on there is a whole bunch of rehabilitation technologies, neuromodulation devices, functional electrical stimulation, VR, AR devices, sensors, and what should progress to our clinical practice? How do we decide? How do we help industry move through the FDA, CE, CMS process? So I also run the Technology Innovation Hub for the hospital, which is outside of my own research. Plus, I have a tech immersion clinic where it is a clinic meant for patients who have tried standard of care in rehabilitation and they have reached a certain, what do I call, like a steady state, but they think they can do more, or they're super impaired and standard of care doesn't provide any advanced goals for them. So they could come to our clinic where we have the access to a lot of the world's technologies which have been commercialized, but purely a lot of hospitals cannot buy it due to financial reasons or to the fact that it takes a little more time to set up a device. In our clinic, we don't have a time span, right? Regular reimbursement only pays for an hour of P or OT and 45 minutes for PT or OT in an outpatient setting. An hour in inpatient and 45 minutes in outpatient. Sometimes you might have a sophisticated robot, but it takes 15 minutes to set up. So a clinician might not want to do that because they only have 45 minutes. But in my clinic, I don't have that kind of time reason. You can go for 3 hours if we need it. So we also run a tech immersion clinic where we immerse technology for care for patients. So these are all the multiple roles, but with exoskeletons purely, I work predominantly on lower extremity exoskeletons. I have worked on a few upper extremity devices, but majority is lower extremity exoskeletons.
Wow.
That's just a lot of work. I didn't know about the tech immersion lab. Wow. I knew about some of the other things, but that's a lot of hats to wear and a lot of things to organize. So
and it's almost streamlined because the idea is to take some of these technologies and you can wait for R&D to do the research and publish the papers, but by the time it's ready for clinical use, a new technology comes. So the tech immersion clinic is almost to bridge that. I don't want to wait 10 years before something. So we're kind of quickly transitioning to clinical practice. So as I gain more knowledge in my clinic, I would then write a practice guideline and transition to everyday practice. So I'm almost expediting the process because a lot of times good technology falls through the crack because you're waiting for those papers to be published and then you want the company to develop its sales team and commercialize it and then come to the pipeline. So we're kind of trying to expedite that process.
yeah, I mean, I knew you guys were a premier lab always pushing the boundaries and focusing on technology, but that's really interesting. So I guess a thought would be, could you talk to us about like that process that you just said, like, I want to build a medical, just, related to me, let's say I want to build a powered ankle orthosis. And can you kind of maybe walk us through some of those steps? You almost talked about a little bit about, you got to get the technology and then you got to do the research and then and then it's got to transition into FDA. So maybe could you talk to us about, and our listeners, about why it does take, as you said, that 10 years to get, let's say, a device to the market?
Yeah, it's a great question. And this is the biggest problem, right? It's almost the most convoluted problem we have to deal with on an everyday basis. And I've thought about this a lot. And so it's almost like it's an odd story, and you can write a book on this, but we'll start off, right? The first exoskeletons, and the same goes to powered orthotics and powered prosthetics. We'll just go with the exoskeletons, right? The first time I saw an exoskeleton was, I think, probably 2008, 9. I don't remember exact dates. I was in Midtown Manhattan, and Rewalk had brought in their pilot with their exoskeleton, and me and my postdoc mentor, Ziv Reimer, we had gone there to Midtown Manhattan. We were in a Days Inn or something. I forgot where we were. This guy walks around in an exoskeleton. He was a paratrooper who had fallen and got injured, and he was one of their the original pilots who had hundreds of hours of using it, right? And that is a mind-blowing experience to see a spinally injured patient who's wheelchair bound is walking, right? And then that triggers this super excitement of how the field in rehab started, right? Boom, you have this, and you were like, wow, I can't believe it. And then I think a year later, I saw Honda at their Detroit Auto Show, so their hip exoskeleton, where they were saying older Japanese were walking better with their hip. So that was the first, other than the Locomat, which is the treadmill-based exoskeleton, which I've seen for years. And a lot of the work we did at that time, the Rehab Institute of Chicago, or RIC, was to change the controller or the help with the hardware design of the Locomat. That was already going on. So we had insight into what exoskeletons were. And when we saw these overground exoskeletons, not the treadmill-based one, the engineering marvel is what comes into mind. Now you have a patient who's never walk. But now that's where all the issues start, right? Now we have a company which is selling a product, but the FDA regulates that the patient has to have a family member or a caregiver behind them full time. And the only controller they had released, Rewalk had a stairs controller because he showed me stairs in 2000, that early stage. But the FDA only authorized that you could walk level ground only and should have a caregiver. Now, I tried it that same day and fell down 3 times. I couldn't trigger it because it had a tilt sensor on its shoulder. And as you tilt forward, a right leg comes and you got to go back and then tilt forward. And then the left leg comes and then you got to go back and tilt forward. So you got to know how to sync. This is the original Rewalk. Things have gotten significantly better now. But it's just not intuitive when you do it, right? And so you are now trying to sell a product which is over 70,000, 75,000. I don't remember what it was. And there are certain issues on what you can do with it. So you have the shock and awe of a spinally injured person standing and walk. But when you bring it to a reality of a clinical practice, when we did a study, it takes anywhere between 25 to 70 sessions before somebody could learn how to walk. Now, for 25 to 70 sessions, you have to pay for a PT, you have to pay for a research assistant or somebody or a technical assistant to brace in front while one's in the back, and you got to walk. I'm just saying, this is a simple problem, right? And how many people have the financials to pay for the device? At that time, it wasn't reimbursed. And to make sure you walk with it and learn how to walk with it. Now, you're talking about 25 to 75 sessions of cash payment system, and nobody's reimbursing. And they were suggesting you can use it as under the therapy billing process. But even within therapy billing, there is a limited number of sessions which are approved. And very few users could walk even after that comfortably. So you had that quandary starting off right there. Now, the opposite side, Rewalk or Exobionics, who had started to come by then, it needs to sell enough devices because they've taken investor money, 20, 30, 40 million, I don't know how much. Your burn rate's very high because these companies are doing these big dog and pony shows at the big conferences. They're putting up booths. They're paying for these lunches and dinners, and they're doing all that. So you understand the industry at one side is burning cash, and they have to sell enough devices to make the return of investment to these investors who are expecting a high rate of return. The marketing team and sales team is pushing this magnificent engineering marvel, which is truly a engineering marvel. But the clinical reality is patients are not able to walk very comfortably with it, and they can only walk, even if they learn to walk, is level ground. This is where the problem starts. And now there's not enough money because enough devices are not sold because they're so expensive. Enough money is not going in back to the company, which can put it into R&D to work to the next level of controllers and different state machines. They don't have money. So R&D is just sitting because they don't have cash revenue. And as they don't have less cash revenue and the investors are pushing, they're increasing the cost of the device because they need money. Or they keep fundraising more and they're getting more loans, which means they need more money to be returned. So now the focus has gone away with R&D, and marketing is pushing harder and harder, which means they are forced to oversell and say, this can do everything. The truth is, it can do everything. They keep showing that one pilot who walks great, but the average person who uses it doesn't walk that well. None of you sell it to the VA as the next best thing. and the VA authorizes it, and there are big studies going on in it. And I called the chief of the VA and said, it's too early, don't do it yet. But the problem is, now you have the researchers. Now that's like me. As you and Tom spoke about, we're always figuring a way to sustain, keep our labs going, and to do cutting edge research, because we do care about patients and we do want them to get better, but that is not as straightforward. Now you're writing grants, and by the time you get the money, and everybody is writing these grants on exoskeletons because it's the new hot topic, and then it's reviewed and you get the money. But then those take years and years to work with the company, contracting, opening up their software so you can give them feedback on controller, hardware, clinical outcomes. So you now have the researchers doing things, trying to publish papers. You have the companies which are now working on a loan because they have to repay their investors. You have these patients who are watching these YouTube videos and feeling like the next best thing has come out, but they're disillusioned when they actually tried. It's not doing what they're supposed to do. And then you have the original engineers who designed it, who are just shell-shocked at where their engineering efforts, which is for the first time a human walking after an injury, is now they're caught up in the middle. So you have all these players just merged and mixed and fighting these. Now comes another company. Now Exo and Rework are competing to the same patients. Now you have, again, the FDA only approves level ground walking. Now you have 2 devices. Then Parker Hannifin comes in with Michael Goldfarb's Indigo. Now you have 3 devices, but only level ground walking. Now all these companies are now selling to a lesser population because now you have 3 players fighting for the same subpopulation of spinal cord injury. And now all of them are costing between $70,000 to $125,000. All of them are trying to update their software, their controllers, as they learn from more patient use in real time with very little money they have, because it just takes forever for a research grant to get funded and that collaboration to happen, and that goes back and forth. And some of them try that because they don't have enough money. So they're like, hey, I'm going to give Tom an NIH grant or an SBIR. Let Tom work on the controller and make it better for me. But then Tom usually is in an academic institute who doesn't have access to patients. Now Tom has got to go make a collaboration with Burrow or somebody. He's got to find that. By the time he makes that collaboration and does the paperwork and then gets this first patient, it's about 2 years. And the IRB asks 700 questions. So you are working on a very complicated system where everybody means good, but just the system is not ready. Because now you've oversold a technology as Iron Man suit for spinal cord injury, but the FDA has handcuffed you from only doing level ground walking. And because you're handcuffed, you can only sell so many because everybody's like, okay, why am I paying $70,000 to $100,000 for walking over ground and I need my mom or sister to be with me? And then that's how they go into therapy robotics. As they go into therapy robotics, again, the question comes, you need to do a 1-week training of the therapist, which means who's going to pay for 1 week of salary of all these clinicians to be trained? And then what is that they want to do? And they slowly learn out that walking a patient on a treadmill with bodyweight support with an existing equipment is zero sum because they've already bought the equipment. Now you're putting in a capital investment of $125,000 to buy an exoskeleton. Then how are you going to get the return of investment? How many patients do you need to see to make that money back? Not every hospital is like mine with a larger budget or a capability or an understanding that R&D is required before technology becomes everyday practice. Most hospitals are CapEx. They can only buy certain things. Now, instead of a cycle, FES bike, they've bought this exoskeleton. And they're like spamming it with all these patients because they need to make the money back. So what happens is you have patients who actually need to walk on it, who will benefit from it walking. But you have a whole set of patients who should never get into an exoskeleton also getting on it because they are trying to use the device to the maximum capability. So you have 10 people getting worse, 10 people getting better. Standard deviation means nobody got better. So then everybody's like, oh, exoskeletons are useless because all these 10 patients got worse. The truth is they put the wrong patients on it. But you can't tell that to a hospital, which his biggest investment was the exoskeleton. And the sales and marketing guys for these companies, for their own reason, are putting up banners everywhere and saying, X hospital has our device and it's the best thing and you can use it to every population. So there is a complicated process. You now see where we're all going.
Yeah. Yes, I see where we're all going with it. And and thank you for explaining how complicated it is. And it's tough. I mean, you've got the business aspects, you got the FDA aspects, and I'm glad you got into those. And then you have the research aspects and all that. Can we
And
go?
then we have the whole field. So now you also have clicks in every field. there are engineering cliques who think these oversized robots are a bad idea. They shouldn't be done. Then you have clinical cliques, groups who do not like technology. And they fight the American Physical Therapy Association and say, don't use them. Robots are bad. You shouldn't be using them. So you have that group. And you're fighting that group because they feel in a fear, good reasons. Everybody means good. Everybody in this group means good, right? They fear the clinicians or jobs are going to be taken away by the robots. And then another group thinks, why are we wasting money on robots when the same thing can be done with a treadmill? That is because when you buy an expensive technology, every patient is being put on it. People who can just walk normally, who just need to walk with a cane, is sitting in a robot now walking. And they're like, that's meaningless. Why are you putting a patient who's not needed to be on a robot in a robot? You understand what I'm saying? It's like me buying a sushi knife in Japan. And because I paid so much money for it, I'm cutting cabbage, potatoes, everything with it. And my friend who helped me buy it in Japan, he was screaming at me. He was like, that is meant to cut the best meat so a single cell in the fish is not damaged. But a person like me who spent $200 on a knife, that is ridiculous amount of money spent on a knife that I am chopping everything with it. That is exactly what happens with these robots. These exoskeletons are beautiful engineering marvels, but when you have paid so much, you're forced to use it on everybody and anybody, which damages the reputation because, as I said, X amount get better and X get worse. Some don't show any improvement. And you're like, okay, robot sucks, but it's not that the robot is wrong. There is no proper practice guideline on who to use it for. Who's the inclusion criteria? Who's the exclusion criteria? Who should be used to? And when do you wean them off the robot? When do you put them on? And then enough controller strategies have to come where you can progress them within the robot. A lot of times in the beginning was just a passive walking. You're just walking passively, nothing. Then when you get off the robot, you're back in your wheelchair. So you haven't gained anything in walking the robot. It's a good feeling. Psychologically, you're walking. Only then came variable assist. Then it came assisted needed. Then they combined FES with the robots. All that came later and later. But by then, in this world of social media and other instant information, damages were starting to be done. So we're kind of doing damage control all the time. If I publish one paper which shows them to be good, somebody else in another field who doesn't have the same engineering and clinical background has published a paper which says robots don't work. And then the person who wants to capture that information goes on and says, this is why we say robots don't work. So for every 5 good studies, there are 5 bad studies. So they pick the 5 bad studies and put it into a national policy saying robots don't work. Here are the 5 studies which show they don't work. So now getting reimbursement got pushed and pushed and pushed.
But yeah.
And to be fair, real quick, to be fair, there is improvements, there's progress. For example, now the FDA has approved the Rewalk, renamed as the LifeWard for stairs. So, I think it's important to know.
Just remember that is in 2008. I saw it. It's 2025.
Yes, yeah, that definitely.
So that's perspective for our users, because this is why we wanted you here, because for our users to know, Arun has probably tested more exos than anyone else out there. But what I wanted to get at, exactly what Bobby was saying, is let's talk a little bit about some of the successes now that we're having, because Bobby had a story on how these systems are now going to be approved at a pretty high rate, right? Like it was around $75,000, I thought, or something, Bobby, right? Because Bobby has an article on Exoskeleton Report about, there is FDA approval for these devices. Some other positive things I just want to throw out there was I was in France for the Olympics, and Wondercraft was there showing off a device in France, and Wondercraft is a French company. So could you tell us,
it sounded like a Debbie Downer earlier.
Yeah, we did a little Debbie Downer a bit. I 100%. Could you tell us about maybe?
Yeah, this is the perfect time.
Here's
more success stories.
More that I saw really work and well. Like, I'll give you one quick thing for my mind. I met you I think it was in Spain with, one of Jose Ponce's fantastic conferences, and we were in Spain, and you had and I liked your pragmatic work where you said, here's a hip exoskeleton from Honda. I'm not telling you that it made their gait, quote, better, but what I am going to tell you is, if they didn't have the robot, they were walking like 1,000 steps a day. I'm making this up approximately. And if they did have the robot, they were walking 3,000 steps a day. I'm not saying that the gait was perfect, but at least they were getting up, at least they were walking, and they were moving. So Could you give us some,
Yeah,
here's
for
things where like, hey, I think this is the right path. Like what you just said, FES with a
yeah.
hip hip device,
And I'll give you great
the
examples.
treadmill or give us some success stories.
Oh, there are more than enough success stories. I mean, just to give you some clarity, the reason I explained the first part where it looked a little depressing was the difficulty the field faces. I just want people to understand when they get into it that you will have to waddle to the swamp and entangle all these difficult things. As long as you're ready to do that, we're in one of the best up curves of the field right now. And I'll give you great examples. For example, and you want to split robotics exoskeletons in healthcare, at least in a very simplified form, into three ways. The therapeutic robots. You use it for therapy, which means you're measuring somebody outside of the robot. You train them with the robot and you measure them outside the robot again, which means you're showing there is a therapeutic benefit with the exoskeleton.
Okay.
That is what we're using. And personal mobility exoskeletons means severe injury. I can't walk ever. I've tried everything. I just want to walk, sit to stand and do things. You're using it as personal mobility. That is very different. So Rewalk and Indigo, and I think even Watercraft's up to get it. These devices are Medicare reimbursable, or CMS provides reimbursement for personal mobility. That is a different thing. So you want to be very clear on personal mobility. That is, home and community use. And the third is performance augmentation. A lot of the modular or the cable robots, or like Tom, your hip robot, they augment performance. They're an intermediate between therapy and personal mobility, which means they're augmenting your performance from improving exercise tolerance, or just you can walk, but you fatigue going to the grocery store. So you wear it to get there. Doesn't mean you're completely paralyzed like in Rewalk or Indigo, where you need a 100% personal mobility device. Here, it's augmenting your ability for personal mobility, or if you want to exercise, as I said in that Honda trial, it's augmenting a stroke patients to step more. So they're performance augmentation robots. So to just give you some idea, exoskeletons can be simply split into three in this medical field. So what are the big benefits from the therapy exoskeletons, right? A lot of times severe injuries or moderate to severe injuries do not qualify for a lot of gait training and walking and things, purely because it's labor intensive, it's complicated because they have secondary complications. You can't even stand them a lot of times or walk them. But these exoskeletons for the first time allow for a severe stroke, a severe TBI, children with cerebral palsy, ALS patients. A lot of people normally would be wheelchair bound or bedridden in a skilled nursing facility to gain walking. And the more you do that earlier, the better they recover to home and community rather than going to a sniff and being bedridden. The more bedridden you are, it goes down and the mortality morbidity just becomes very high. Here, these robots or exoskeletons allow you to step, walk, simple as that, even in ICUs, where you're just degrading in a real-time basis to get that going. For example, locked-in patients historically have been locked in for life. You're just locked in. But now with exoskeletons, we've seen locked-in patients actually step and go to minimally conscious and then become conscious and actually go home. That historically has never happened because you just can't lift these patients and hold them and move their legs because you need 5-6 people and it's not financially or clinically meaningful to do that. But now an exoskeleton can lift up a locked-in patient, stand them and get them moving. Same to all the severe TBI, stroke, spinal cord injuries, and all the other severe impairments. That's one side. The second, for the first time, we're able to now implant neuromodulation devices like spinal cord stimulators and brain stimulators. But even when you do that, what it does is to enhance the nervous system to recover. And you can take few steps. It's scientifically a marvel, engineeringly a marvel that you can implant things in the brain and the spinal. But what is the next step? You can take a few steps, but that's not what these patients want. They want to walk every day, or they want to move their limbs and eat. And so exoskeletons, now when they sync, they're letting these devices now directly talk through brain-computer interface to these devices, can get these people walking and moving their limbs for the first time. Same way as you walk, historically, your limbs are atrophied after injury. But now you can merge them with functional electrical stimulation or neuromuscular stimulation real time to move. So therapeutically, there's a lot going on. Personal mobility devices, now you have devices like Watercraft and things. The difficulty with the original personal mobility devices, you were holding on to your forearm crutches, a walker that created all this for a safety purpose, but it also made it difficult for somebody to move. Now there are devices which are hands-free, which means you are more balanced. And they allow you to go through ramps and curves and steps. So these personal devices have gotten significantly better because those controllers have become better, the hardware has become better. the engineering is significantly better. So now people are able to more seamlessly walk. So the FDA is approving more capabilities with these devices so that you can go about everyday life instead of having to have a caregiver always behind you. If it's self-balancing, that fear of a caregiver needing to catch you is gone. So self-balancing robots have come in personal mobility. Performance augmentation robots. Now we have robots which weigh 2 pounds and 3 pounds and can run off a smartphone and has AI technology through inboard sensors and can do real-time assistance resistance. You now have children with cerebral palsy walking longer. Otherwise, they would have chosen a wheelchair because it's so difficult to walk. You have elderly or frail elderly walking long distances for recreation or therapy or exercise, and they can sink in and listen to music and walk. You have such lightweight technology that you can hike now. You can go from the Grand Canyon. You can do things which most of us will not choose to do because as you get older or you get even in your 40s, 50s, it just doesn't make sense to hurt yourself trying to do things for it. If you look at the American Heart Association recommendation, you need to walk 7 days a week, 30 minutes. Most of us can't get that. But with these performance augmentation robots, you can get those because it makes it easier for you. It makes it entertaining and it can assist you when you need it, but it can resist you, which means you can get exercise. You can get your heart rate up. You can get that MET level, metabolic equivalence to go up. You can actually get a cardiovascular workout while walking with a wrist, and it strengthens your muscles too, all in one time instead of. So it's a significant benefit. The trick is you have to learn to do this systematically, R&D on it, and quickly publish it. And the industry needs to collaborate with the right engineering and the clinical teams to make a dedicated plan for this. You need to collect quick data on MS, Parkinson's, TBI, locked in, and quickly publish it and go to the FDA. You don't have to even publish. Go to the FDA with the white paper data and get them to give you new approvals. You need to get these devices into the market and have a strategic plan, but that needs a more of a strategic plan with all the exoskeleton companies and the researchers to form an organization, which I know we try to form and work on and work seamlessly to the betterment of each other. Working in silos is difficult. Arbach, Oser, all Hanger, all these big prosthetic Norcan, even though they're competitors, they all work together. They work together on policy, they work together on reimbursement, they work together on things so that their field survives and is protected. The same needs to happen in exoskeleton. That doesn't. It's just people working in silos and competing and doing things. If they work in, these are brilliant technologies. I think it's unfair how they haven't gotten their bang for their buck. But that is because of lack of knowledge on how to use them. And all these examples I've seen is not in one case study. I'm talking about 30 patients, 50 patients, 20 patients. There's constantly large sample sizes. It's ridiculous how many samples and how many papers we publish. Yes, what happens, my H-index goes up because people will reference it and write a paper, but it doesn't have a clinical impact. That is what I care about, right? Yes, it's great, but after a certain amount of time for me and Tom, any more papers or any more citations doesn't rock our boat that much. It's what happens to the everyday patient. You design these. That is
Thank you for that. Let me add some context for all the listeners. When Arun is describing these type of exoskeletons, assistive augmentation for purposes of rehabilitation and functional improvement versus mobility, all of that is on the exoskeleton report. In the catalog, you will see assistive augmentation, you will see personal use, you see those divisions. And that is not by accident, because Arun over the years has spent a lot of time and energy to help me develop and understand what are the different devices that are out there and what are the different, what are the different end goals that they're trying to achieve. So thank you, Arun, for putting in that time and effort. Furthermore, when Arun gives us here a call to action that we need to bring our efforts together as an industry and not be in different silos, he's not just saying that while sitting down. He has spent years putting together the Wearable medical track and bringing in all of these medical companies together for the very first time, which was all effort behind the curtains that really no one knows about. So thank you for doing that. It's a call to action, and you have tried to do something about it.
Yeah. Thank you. Yes, Arun, probably here's a guess, probably helped to run 6 of the Wearacons, let's say, and do the medical tracks. But let me just ask this question. Where would people go to try to, so I'll give a place where people can go to try to combine. Schneider has been running an Exo Park. He's been running a Exo Workathlon, and he'll be hosting a Wearacon Europe, where a lot of European and Asian companies are coming together. I'll give some other ideas like Assist Suit, I think, in Japan is thinking, I think more so on occupational exoskeletons, I think, Bobby.
Yeah, both of those.
Which one?
Yeah, you're right. They're all occupational.
But for the medical side, Bobby and I have been looking around, and so we've talked with Modus Academy. There's American Bionics. We also looked at, there was an ACRM, I think it is, Bobby, ACRM conference where there's a lot of medical exoskeletons go there. So, like, Arun, where would you go right now to say, hey, we need to come together to try to push the medical exoskeleton field? If you were to go to a conference right now, where would you go?
Yeah, and I think that's why I was excited about Wearacon, unfortunately, because that was the only go-to place. I mean, Biorob exists, and there are other ones. I forgot there's then we have ICRA, ICOR. Fundamentally, again, those are all very smart IEEE engineering conferences most of the time. They're meant for engineers to talk about hardware design controls, AI-driven controls now. What's the next thing in that stuff, right? This is a little more nuanced in a way that the engineering is good. We've always had very good engineering. Now, what do we do with the existing technologies which are commercialized? How do you teach the mom and pop clinics, the mid-level hospitals, the big hospitals, the research institutes to use these devices appropriately so the knowledge spreads? Like FES, for example, was the big thing 15, 20 years ago. Then it died. Now it's making a comeback. It's like that. We're living through the era where these beautiful technologies were designed, but we're also living through the era where people are struggling to understand how to use them, and they're slowly picking up. The interaction needs to tell the future designers, hey, what is that you need to do? Like, they're doing brain-machine interface, right? Neuralink is going to do exoskeleton work. Onward is another BCI company which is going to do exoskeleton work, where they're trying to, as you think they want the robot to move, instead of having to use a key fob, because they're trying to figure it out how to make it easy. But now we got to teach them what is that needs to be done. We don't want to do that. The original Reebok story I told you, where the BCI works perfectly, and it's awesome for that first Nature paper, where you got up and you've now shown a brain-machine interface, getting a robot to stand up and work. That's a Nature or a Science paper. That's great. But then after that, what happens is, then if you want to put it on the next 20 people, they all want to go home with it. It's not the science now, it's reality. So there is always this interaction effect between science and reality. For science, that is the greatest achievement. So science has to keep developing on one side. Robots have to keep designed, and exoskeletons have to get better. That's one division. I'm talking about the other end of the spectrum of the everyday patient family. When you sit with them and say your child has a spinal cord injury, now they're like, what is that out there? I saw this YouTube video of this brain interface and this stimulator and this exoskeleton. Can my child get it? Is the question we have to always answer 100% of the time. That's what they are. What is the best out there? They always ask us. We're willing to sell everything. We're wanting to put it on our child. But that's the trick, where when a person is willing to sell everything they have for their child, you want that to be actually beneficial. And that's what I always have to play that quasi Debbie Downer saying, hey, it's not ready for prime time, guys. You got to stop. You don't want to do that now, because I know it's not yet ready where you can it's not a plug and play, where you put it on and then boom, you gone home. There is so much training, and we're in the base controller strategy. We need to. So that is the process where we somehow to streamline and educate that, okay, these robots are plug and play. These exoskeletons are ready for prime time. These need more work. And how do we get it faster? Because a lot of times it takes decades, and we can't afford that. So to protect the field, we need to progress the science faster and the clinical trials faster, and we get the evidence. I mean, clinical trials are not just meant to test somebody's device and say it's better or worse. It's also to give feedback. It's a feed-forward mechanism. We have to give feedback and say, hey, you need to go fix this. And that's why you don't want to go into a large-scale randomized control trial. I always say, don't go there yet. Because is your exoskeleton that perfect that you ready to box with the best clinical care? No. So you want to keep developing it. Then this is going to knock the socks out of so many diseases which doesn't currently have a recovery strategy. Yes, is it going to solve all diseases? No. Because a lot of strokes, for example, I would say 30% of strokes walk and go home after their stroke. They come in, get admitted, they get the medication, they're fine, they go walking. Nothing, not even a cane crutch, nothing. Then you have a bunch of them who will recover with just regular therapy. But there's a whole bunch of them who don't recover at all. That's where the exoskeleton comes in. This goes to every disease. And same goes to the aging population. Everybody will write you an exercise prescription. Yeah, sure. Your grandmother needs to walk. Your mom needs to walk. Yeah, everybody knows that. Who walks? Oh, my knee's hurt. I'm tired. I don't want to walk. My back's killing me. That's where the exoskeleton comes in. It's going to prevent you from hurting your back. It's going to give you that assistance where your knees don't hurt, but it's still going to get you walking so your heart rate goes up. And over time, she can go down and say, I don't need this much assistance. I can reduce it because I'm not gotten better. My strength is improving. My back's not hurting that much. Some of them will wean off it eventually. Some of them will still need it at a mild level. That's when VR is now coming. They can play games at home. They can walk at home. They can hike the Alps if they want to. So I think those are all significantly positive, but it needs almost a work group and a large group of people who meet every year and discuss it and say, hey, and be accepting of here's our cons. This is what we need to work on. Here are pros. How do we push that? But if you purely let industry drive it, they are burdened by the investments. So they have to oversell. If they oversell, you're going to have a bunch of people happy, but a whole bunch of people disillusioned and unhappy with the oversell. That can be only prevented if a large group of people work together and educate people, improve the clinical use. The same goes to industry exoskeletons, right? There has to be more data showing, even though immediately you won't see a difference, long term, you're going to prevent injuries. You're not loading on the wrong side of a bone or a muscle, which is going to tear that long term. The life of an industry worker gets expanded. The ability to cause immediate injuries or anything might get better. Yes, they might not be able to lift extra like we are all hoping, 500 pounds extra or something. There's no superhuman though. But mechanically bad loading, this was obviously even powered prosthetics, and Tom knows that, right? If an amputee loads significantly on their non-amputated side, over time, most of these amputees end up with hip replacement, knee replacement, and back surgery because they're loading their non-injured side so much because the prosthetics divide. So that's why powered prosthetics, when they were introduced, and even if it balances it out, they might not walk faster or walk longer distances, which is their traditional clinical outcomes. Oh, they're not walking any faster. They're not walking more long distance. Metabolics is not improved. Yeah, but if we notice that the symmetry of walking has become similar, which means the loading of the amputated side and the non-injured side are equal now, which means they're not going to overcompensate and overload. And now you're preventing expensive surgeries and surgeries with high mortality morbidity rates like back surgery and hip replacement, knee replacements. Those are huge things. That's the same with industry exoskeletons and therapeutic devices. There is no instant magic. A spinally injured person walking long-term, you prevent osteopenia, osteoporosis, cardiovascular disease, non-insulin dependent diabetes. Because most people with spinal cord injury don't die due to the injury, they die due to secondary complications. But those are years to develop. You don't get cardiovascular disease immediately. If you are on a wheelchair, not walking in your blood, you are gaining weight and you're not having that same exercise tolerance, you start to get those. And over time, you develop it. And then they'll say, oh, they just got old and died of cardiovascular. No, it's because of the lack of walking, exercise. So the exoskeleton is going to limit that. It gives you a better quality of life. But there are super hard studies to implement. I have to totally have two groups. One group doesn't get anything and they're following them in the wheelchair, and another group walks with the exoskeleton regularly, and then I have to prove that. That'll be like 10-year study. Nobody's going to ever fund it. Even though we did write one with Chad Swank out of, forgetting where he's at, Baylor Scott, a cardiometabolic impact of personal exoskeletons to PCORI grant funding it. Hopefully we get it. That is a long-term study to look at the benefits of exoskeletons.
And especially in this culture right now where we are obsessed in business for quarterly results. And culturally, the US has shifted more and more from thinking long-term to thinking short-term, seeing that immediate result. That's always a question on how do we get the users to feel something immediately rather than telling them, yeah, in a while you're going to see huge benefit. But I kind of want to basically almost pause. I thought, Arun, that you were part of the planning committee for RehabWeek 2025 in Chicago.
Yes. I mean, it is one of the largest rehab conferences purely for the fact that I think 8 different conferences come together. ACRM, ICOR, which is the International Congress of Rehab Robotics, RESNA, which is the Rehab Engineering Society of North America, and then there are Motus Academy, IFES, which is the International FES group, ISVR, I think International Society for Virtual Reality, and a few others. I'm forgetting the names, but this is the largest group of rehab European, Asian, and US based conferences all merging together. It's to create this, what do you call, melting pot of scientists, engineers, clinicians, industry partners, because it's very industry heavy. This meeting is a lot of industry partners from Europe, especially, and we're trying to drum it up so they all can meet and engage and interact. And we want to create this exact what I was talking about. We have tours of our hospital, the Shirley Ryan AbilityLab. We want people to come and see what the hospital is like. What is patients going through? What are the R&D happens here? What is a nice idea from a purely engineering standpoint? How do you transition to a clinical standpoint? So we're super excited about it. We expect a ton of people to show up, from students to scientists to industry partners. So I think it'll be a great opportunity.
And we're talking here about Rehab Week 2025 in Chicago, May 12 to 16.
Yeah, no, that's really positive, because that is getting at like what you were talking about earlier in the discussion, where you said we need to create an ecosystem. It can't just be, high-end engineers focusing here and then clinicians over here focusing there. How can we create an ecosystem where we're working together to make sure that we're improving, the quality of life?
Again, there's a complexity in this, right? So, for example, standard of care. What is standard of care? In rehabilitation, 2,000 US hospitals, which have a very different standard of care. And then European standard of care. France has a different standard of care. Germany has a different standard of care. Poland has a different standard of care. So everybody has their own standard of care, which means you could have a spinal cord injury and be in a rehab hospital for a year in Switzerland. While in the US, you got 12 weeks. So now when you introduce a technology, we're driven by outcomes in the United States. It's based on what your outcomes are. It's value-based payment, which means you have such a short time and reimbursement's only going to pay for that. So unless the exoskeleton gives you that burst of performance, there is no return to investment. While in Switzerland, that's fine. You're going to be in the hospital for 12 months. They're okay trying an exoskeleton slowly for 3 months to tap its potential. So, which is why a lot of times a trial done in Switzerland has a completely different outcomes for the same population to a trial done in the United States. So that is another complexity you will have to deal with also, because practice guidelines change. And now when you have there's so much pressure on an exoskeleton to outperform all this and shine and climb up on this and say, I'm good, guys. I'm really helpful, because they'll be like, whoa, these robots or exoskeletons have shown, even if it's shown equivalency, an exoskeleton is doing as good as the best trained clinicians in the top rehab hospital in the country for 30 years, which means a robot on its own is working as somebody with so much knowledge, clinical knowledge, and is doing so much customized care for a patient. And the outcomes you get with the patient is the same level of just walking with a robot. Do you know what I'm saying? It's like you doing an AI Mozart song and it's at the same quality as Mozart is a shocker that AI is developed at that level that you can match it, right? The same way. And this person is doing super high quality customized care. If an exoskeleton can even provide equivalency, which is why a lot of studies, the results were equal. Oh, that is such a bad thing. No, it's not inferior, it's equal. Just walking with an exoskeleton gave you the same results as a superior clinician. And an exoskeleton at home, a lot of times I get dinged, the results are equal. Do you understand that now there is no therapist at home, and an exoskeleton gives you the same results as a super specialized clinician training the patient in a clinic at home? Do you realize what a marvel that is? That is, I strap it on and my mom's walking on it and she got the same results as coming to a therapy clinic, driving, have somebody bring her, and she's going to this clinician and learning all this. So these robots are significant. The quality they provide is brilliant, actually. But in a scientific standpoint, if you say study has equivalency results and not statistically significant, that sounds like a bad thing, because, the robot's not superior. Yeah, but the robot is as good as the top clinician, right? Because they have so much inherent knowledge and it's doing almost similar. So that itself is, in my opinion, a great achievement.
That is an excellent point.
That's an excellent
Thank you for bringing that up.
point before. How about just something in my head? Where do you think these exoskeletons can go and make a big difference? Like, here's something in my head, because I had some, family knowledge on this lately. You can look at basically independent living places, assisted living places, and then even skilled nursing. And then, yeah, you're going to the hospital for rehab. But what about, I'm just throwing this out there, what about maybe in between this independent living and assisted living, right? So I'm in assisted living. I'm in a really nice facility. Some of these facilities are quite nice, right? But I'm in my own room. I'm in assisted living, but now I wear a device to get me up and go out, and I do a 1 mile walk once a day or something like that. Instead of, I'll just, as we talked about a little bit earlier in the discussion, a lot of times I'll just sit at home in my apartment and watch TV, right? So what do you think? Where do you think, like, just a thought process, where do you think exoskeletons can
There's
make
two regions. Yeah, I think for the companies, for the scientists, for the engineers, there's two areas they have to focus in medical field. One is the severe injuries. Right now, they are all almost left to kind of, they give up on them a lot of time. Not that they're totally giving up on them, but they're meant for, as you said, skilled nursing, SNFs, and long-term living facilities, and no recovery. But the healthcare burden on that is significant because they get readmitted to the hospital, they get more sick, they get infection, they get other things. Significant healthcare burden. They will significantly benefit from early mobility and walking with both upper limb and lower limb for the exoskeletons. It's a massive area where you can reduce healthcare costs significantly. That's one. The second is the whole home and community. Our whole population is starting to age, and we have all these medical complications. And our biggest the reason for it is lack of mobility and exercise and fitness and injuries and hospitalizations and sickness, everything, diabetes, all the big conditions related to exercise, lack of exercise and fitness, therapy. These robots can be that bridge. So again, not replacing a therapist, but helping a therapist, augmenting a therapist's home prescription, exercise prescription, or trainers. It's like a Peloton. Why is it so addictive? Because somebody's online telling you to do it, so you feel a little motivated and you're jumping on it and you're using a Peloton bike. If I didn't have that interaction and I had to use the bike on my own, maybe I'm not that motivated and I have to walk. What were people doing before that? Were they not ever exercising? So that is the trick, right? You have now a tool and a technology which can give you that exercise capability. Either you can walk longer distances, get your heart rate going, or you can make it harder when you walk short distances, getting your heart rate going. You can make it an endurance exercise, or you can make it a strength and fitness exercise or resistance exercise. So that is a massive market, both from an industry standpoint, from a clinical standpoint, and an engineering standpoint. As they get lighter, easier to use, and more intuitive, you can add more bells and whistles. You're solving a big endemic issue we have in our country, which is obesity, diabetes, health fitness issues, all these injuries, hip replacement, knee replacement. That is a market. Because of what? Poor strength, endurance. Over time, you're grinding on that leg and then the bone scratching over another bone and your knee replacement or hip replacement. But if you had the muscle and the strength and the cardiovascular issues, then you don't need those cabbages, those cardiac surgeries. And everybody's getting them now like candy almost. All that can be limited or at least delayed by just walking and arm use. Why you don't want to walk, as I said previously, it's too tiring. But now the robot helps you do it. Soon they'll engage with you. You can now they sync to your Spotify playlist. Soon you can even talk to it as you walk.
Well, I liked your example though, of Peloton. I mean, why not just have Pelotons at an assisted living or independent living place, and you just do? I mean, what do you think?
Because again, you get tired. Peloton doesn't help you bike. You have to still put resistance. You can do it, but skeleton is a little different because it's helping you. I mean, not everybody is just efficient on their own, right? We all know we have to exercise. Tom, why are we not going to the gym?
I know you get lazy,
but exactly right. You get lazy. So if you can just sit in your chair and you just strap on a robot, and let's say you have to walk through one of those parking lots and you can park a little further away, and it would give you that exercise, 20-minute exercise as you walk to the parking lot, you would do it because now you knocked one thing out of your list because you're a busy person. You don't have to worry about it. Right. Otherwise, you're going to go home, change into your shoes, go for a run. Because now your wife's going to ask, well, who's going to do something else? And when are you coming back? So you cut all that stuff out of me. Everybody's busy or tired or lazy or whatever it is. I'm not saying it's for everyone, but it's totally going to. We did this study with Samsung in a skilled nursing facility, not a skilled nursing, it's one of those fancy assisted living facilities, right? 12 sessions. And we published this paper. It's 12 sessions. These people, everything went statistically, clinically significant. Their walking, the number of steps they took, their metabolics, their balance, their reduction in fall risk. They were so detrained. Most of the time they were playing bingo and going to happy hour. Right? And they were just not doing anything. So an easy intuitive robot, boom, these people just 12 sessions showed clinical meaningful improvements in all these patients.
So to give the users or listeners, give the listeners some ideas. I think you're talking about a really intuitive Samsung hip exoskeleton. Get them in a hip exoskeleton. Just get them doing some steps. And if you did
walking stairs, ramps, indoors, outdoors, in their garden, boom, their exercise tolerance went up. The number of steps they took, because we did a baseline where we measured them for 2 weeks without the exoskeleton and just measured what were they all up to. And then we used that as their baseline. Then we trained them for 12 sessions and then we did a post-test. It was statistically significant in every measure we took.
You're saying their heart looked better, let's say the cholesterol looked better, all these.
Fit into the cholesterol, heart rate, steps taken, metabolic efficiency, balance, gait speed, endurance, everything.
Your work, Arun, is very pragmatic, where it's just like, hey, I'm going to find a device that's going to make a difference, and it's going to make a difference in these, really fancy, which is fine, really fancy independent living or assisted living places. Because that's where, as you said, we've got to keep these people active, because everyone in the world has an aging population. That's just it. That's, where we're at. And Asia is much further along.
This helps the whole ecosystem I talked about, right? Now you get companies who can sell a lot more products, which means they will have more money going into R&D, which means they will be able to sell the products at lower cost, which means, again, a lot more products are sold, more money goes to R&D, you have the next generation of better looking robots, and we're solving this ecosystem. So you don't have to do a hard sell, you don't have to oversell. It takes care of itself. Same way as you see these medically complex patients walk better, get out, get discharged, return home. You're not spending millions on them on readmissions, and the healthcare economics gets better, boom. But that needs a systematic approach. Right now, it's like throwing everything on the wall and see what catches. So there is this scattered calamity almost where everything seems all over the place. And that can cause this progression to be delayed. That's all I'm saying.
Yeah. Well, we like to say once that getting old is not a disease. And so I thought this is the case. Please actually tell us if this is true, that I don't need FDA approval for an exoskeleton if it's just for, let's say, exercise or endurance, right? So like definitely the occupational exoskeletons.
I think you have to register it as a class 1 device for exercise, but you do need FDA registration. It's up to the FDA to decide whether they still consider the class 1, class 2.
I'm going to let the FDA, you're right. We should not make anything there. But I guess what I'm getting at is getting devices to make a big difference in mobility is important. Because I used to say in my website, I want to improve the quality of life, and which was for medical side. And then I want to improve the quality of work, which was kind of the occupational exoskeleton side. And we were trying to do both of those. And then I don't know if you like this one last quick thing, Arun. I also tried to come up with this meme, exoskeletons just work. So I was just trying to
that is true, right? Like your Air Force hip exoskeleton, right?
Right.
If you look at workman's comp, and I've talked to all the biggest workman's comp people in the world, I've even spoken at multiple workman's comp conferences. It is so expensive for them to pay when a worker is injured. Because not only have to pay for the surgery, everything, and then they're lifelong, they have to pay for this person because they're on workman's comp.
Right.
So they're willing to pay for expensive devices, not as long as they can prevent this injury from happening. So this goes to both, and they are also willing to have workers return to injury. That's why powered prosthetics, for example, they were considering that significantly to be reimbursed, because if you can get the worker back with a powered leg, they're fine. They don't have to pay for that. Cost is so much lesser than the decades of money they have to pay this person if they're not working. And the same with your hip one in the Air Force, right? You get those specialized people injured. It is so expensive to find others to do it. Right. So investing in a hip exo, which can reduce the burden on that person, is significant. But what I still can't put my finger on is where do these things fall through the crack? Why are these things not catching fire? What is happening? I just don't seem to understand that piece.
Yeah.
Because do you know why they don't catch fire? Like, so much evidence exists, but why are they not?
So I'm going to do a couple things, and that's a great, maybe some of the last questions here. It seems to me, and I know people are pushing back on me for saying this, but it seems to me that they're catching on more in Europe. The reason I say that is when I go to like the WorkOn Europe, the A+A conference, you have many, many, many companies working together in an exo park, but they're also, selling devices. They're selling devices in agriculture. They're selling devices in, for workers. And I also think in Europe, they have a different philosophy where it's your job to give the person the best equipment to make sure that they can do the job and do the job healthy and safely. And I don't know that we have that as much in the US. Secondly, I think you're seeing exoskeletons more so in Japan and maybe Asia a little bit more, is because they have an aging population, right?
Why is that people don't see it? Like, I just don't
Yeah.
get it.
So I'm in Silicon Valley, which is the investor capital in the world for new technology. I've had the privilege of talking to VCs, venture capitalists, to roboticists, to innovators, and I see this blank stare when I start talking about exoskeletons. And they're like, how is this going to make me money? How do I know that this is working? A lot of the points that you hit on, like in a short study, we want to see immediately statistical results. We want it to be safe. We want it to be software. We want it to be, we can talk on and on and on, but at the end of the day, I think it's a communications exercise. It's how to market and package it in a way that people can explain it, how to find golden applications where people can't live without it.
Yeah, I think you have to choose that really nice intermediate sales, marketing, and distribution process instead of overselling, instead of underselling. You have to be a little more practical. You have to guide. A lot of these companies just give you a manual. And I keep telling a lot of those company guys, like, hey, you just can't give a manual and expect people to read it and understand how to use an exoskeleton, a sophisticated device. You got to set up an inclusion exclusion. You need to train them. Now, 1 week training program might be good to know how to use the device, but it doesn't know how for them to use it in a severe spinal cord injury to a moderate spinal cord injury, a cervical level spinal cord injury to a thoracic versus a lumbar, because how much muscle control, motor control, sensation, everything changes by these level and type of injuries. To a quad equina injury, to a central cord syndrome, so that level of knowledge needs to be there, so that now if they know all these differences and they treat them appropriately, now you're going to tap the potential. Otherwise, you're just strapping somebody in, turning it on, and you're walking, looks good on a YouTube video. Once they're off the device, they're back in the wheelchair. So what are you solving? So that is the piece of puzzle for all these devices, as now you have TBA approval, MS approval, spinal cord injury approval in all these populations, right? There is so much potential. So
Yeah, and in my experience, I think as an industry, and I'm guilty of that too, I think one mistake that we've done is that we never created a safe environment where people feel comfortable talking about what doesn't work. We have the habit of, here's exoskeleton A, it's the best thing ever, and then 2 years later, here's exoskeleton B. Oh, the exoskeleton A never existed. It's all about exoskeleton B. And then 2 years later, now we are on C. Well, what happened to A and B? Why are we changing it? What did we learn from that? I don't think that we ever created a safe place where people can talk. And by people, I mean, be it clinicians, researchers, marketing teams, engineers, super users, and be able to say this failed here and here and here and here. The first time, and one of the only times I've really heard a presentation like that, was in one of the Department of Defense exoskeleton interchange meeting, where there was a super user who was a pilot. At that time it was called a pilot, now we're calling it a user, for several of these early stage medical exoskeleton companies. And he very objectively spend 20 minutes talking about what doesn't work.
Yeah, and the other clarity is awesome points that you raised. The other clarity we need to provide. I think engineering development is something which is needed. So it's not like exoskeletons don't work, don't do it. Doing engineering work is important. And you have to continue doing high quality engineering work to get them to the next level. What you don't want sometimes to do is at certain level start a company with that. You have to learn that or somehow be educated that that is a path to disaster. Because so much good quality engineering could have been continued done, but when you take that trajectory and start setting up a company, fundraising, you just lose focus sometimes from what. So it's almost better to license it to somebody else, a larger company who has the money to further develop it and take it to that commercial quality level. Starting, I mean, I don't know, and that's a controversial thing to say because a lot of good startups exist, but sometimes I feel like too many of these companies are popping up and you're almost trying to fix it and to do justice to it, but then they also cause damage. But that, and the question is, but what about the engineering development? Yes, R&D has to be so, but you can't make money purely being an R&D company where I'm saying I'm going to develop the next best motor or the next best controller. You have to have a commercial value to it. So it's very hard, and I understand, and that's another piece of the puzzle we need to solve. When is it ready to go to commercialization? When do you start a company? Or when do you learn that, okay, because I know a lot of these companies, not a lot, quite a few, who spend millions and millions, tens of millions trying to get it to commercial level. They've started up a company, they've fundraised, spent a ton of money on their fundraising. You have a sales team, a marketing team. As I said, they go to all these conferences, set up booths, show their device. But actually to even get to that FDA trial where you have to do the safety efficacy, it takes them significant amount of time. By then, the sad news is the next best controller and hardware-based robots already out in the market, or they're opening a company. So by the time you start, you're already here. You've just got an FDA approval, but now you're fighting a technology which is way more superior to you. So this is where the quandary exists also. I don't know, have you felt that or seen that?
Yeah, no, it's definitely a quandary, and I don't have the right answer to it because the small companies are the ones creating innovative technology. Some of the larger companies are the ones that have a sales and marketing team that can actually create market pull.
Yeah,
I think what Bobby was getting out there was like, because I was at a VR AR conference and I felt like they got over a hump and a bridge and people are using, VR systems. Like, I'll give an example. Like, I was like, that makes sense. Like, let's say you're a person and you have to put bolts on an airplane in a certain order. Well, just wear these AR, VR glasses, do the job. It's all recorded that you did what you were supposed to do. Then you put that data into the system and then AI writes a report for you, right? So like to me, they have that moment, right? They have that Excel. Well, it's actually, I think it's Lotus.
See, that is a cost benefit analysis right there, right? It's solving some efficiency issue. But the same thing we've seen, you can do that, and then you have a stroke patient throwing a tennis ball in VR, right? So now you have a $8,000 goggles and this software you have to license. You could throw a regular tennis ball. And the other thing is they're not still recovering their hand function. They're artificially throwing it where they're tricking and doing something. When you finish with the VR, the hand's still like this, crooked, right?
Yeah.
So this is where...
Well, the trick is this. The human being's body and dexterity and movement is special. And we're trying to fix that, right? And so what I was trying to get at there is like, we don't have the Lotus 1, 2, 3 moment yet. And I think we're all looking for that.
Or these companies should be incubating somewhere in a safe environment where they have financials to protect them so they can continue developing their technologies. They're not forced to commercialize because they have financial backing, right? They need a tech incubator where they can keep further developing while they are ready to commercialize. And even if my VR system can only throw a tennis ball, the same my VR system now can help on a Boeing wing. I will make money on the industry business, but I'm willing to spend some of the money in developing my healthcare business.
Right.
Problem is you have a separate healthcare company which doesn't have money again to go back into R&D, so they're just still working on the tennis ball game. While the aircraft company is a separate company. If both these VR companies were one company, money from the Boeing project can go into the R&D for the healthcare. So Next time you can give a tactile feedback. So when they throw the ball, they feel tactile feedback or so. You know what I'm saying? There has to be a product line.
No, I know exactly what you're saying. I don't want to mention any companies by name, but I'll mention some ideas that popped in my head. Like, imagine you're working in ergonomics, right? And so you give people the best chair, you give the people the best stand-up desk, but you can also give people, exoskeleton that can help them walk if needed to, right? So you have some pieces along the line. Or I know that I'll just give one example. I know like Schneider Fraunhofer, they have a very large ergonomics group where exoskeletons is one tool that they have. It's not the only tool, right? They do 10 things, and exoskeletons is one of those 10 things. And so we'll get there. We'll get there.
I think this is a great ramp up time point, but we need, as I said, an area where everybody can talk and not feel. But again, and you all know this, and Tom knows this as much as I do, is as we try to create this melting pot situation, researchers are sometimes handcuffed by grant needs. They have to protect their turf. It's like not a turf war, but at least a turf protection, because you just can't dole out everything to everybody because somebody else is going to write the grant before you could even think about it and get the money. So you are also sometimes limited by that situation. Right?
Yeah, no, that is limiting. I mean, I'm thinking out loud that, maybe where our field needs to go is to find some really, I know this sounds, but find some really high-end foundations that can really say, okay, there's big foundations that said, okay, we're going to focus on lung cancer, big foundations, we're going to focus on heart disease. But where's the massive foundations? And I know there's some, and Bobby has it out there, massive foundations that want to focus on just mobility. We know Toyota was fantastic and they helped us and work on that, but it's just something for the industry to think about. Like,
yeah, it's important. Like the Reeve Foundation and the Nielsen Foundation invested heavy on neuromodulation for spinal cord injury, but the same groups could have put a chunk of money on exoskeletons a long time ago, in my opinion, and that could have helped further develop it and move these devices further along.
Right.
So like that, you need larger donors and foundations and a tech incubator where people can work on the important engineering problems, and then put in some clinicians who can develop manuals and practice guidelines so that you do justice to these extremely high quality technologies.
I'm looking at the time and I'm thinking we should start to wrap up a bit. So what would be some at the end, Arun, like, did we miss anything, or what would be some big takeaways you'd like to say to, it could be to anyone. It could be to the clinicians, it could be to the hospitals, or it could be to those, PhD engineers that have big dreams. And I've had big dreams in that sense.
I think the engineers and the PhD researchers should continue dreaming big and continue further developing these technologies. But I always almost suggest that instead of starting fresh, take existing technologies, look at what their existing problems are and further make them better, rather than going to scratch and say, I want to build another exoskeleton. What is the existing exoskeleton struggling with? What is that I can improve it on? What can I further do? So that means more collaboration because you're trying to get it better. And those companies should be willing to share IP if somebody helps them, pay them what is due fairly. And so that there is more encouragement for people to collaborate than start off silos. And for the clinicians, I think they need to regularly meet and have exoskeleton workshops where they learn from some of the experts around the world on how to use them in the right populations. What is that they do? You don't even have to, if you really understand what the exoskeleton does, then you can find novel clinical information, areas to work on. Then they work with the exoskeleton company to systematically develop the evidence, give it to the exoskeleton company who can then go to the FDA and get a new label for the technologies. If you're waiting for me to write a grant and that gets funded and then I do that study and then give you the data, that's just dragging things longer. It's got to be a systematic approach. Like all the companies say, hey, let's work together. We all work together and figure this out together. It's doable. Then you just have to have Bobby then write letters every day to all these people.
Thank you so much for the closing remarks, Arun. Thank you very much, all of you, for listening to this podcast. I think we were able to touch on this episode on both the medical side, the business side, a little bit on the industrial side, how all of these questions and issues are related to the different applications of exoskeletons. And we're building upon all of our medical episodes. So we had the introductory episode on medical exoskeletons with just Tom and myself. We had Matt Marino tell us what it feels like to be a parent with a child with cerebral palsy and his experience with trying to apply exoskeleton devices and new technology. We've had Dr. Zach learn again from what is it to develop a pediatric medical exoskeleton. And now with this episode, I hope that we're building a knowledge structure. We've had Zen call with Modus Academy on the importance of medical exoskeletons being easy to use. And like Arun said, plug and play in this episode. So I hope that these conversations are building a tapestry for you, our listeners, where when you listen to them, either in order or out of order, you get the full picture and you can get that moment. This is the state of medical exoskeletons. This is what's happening from all the different points of view of this highly interdisciplinary field. So if you enjoyed this work, please support us on Patreon, and we'll catch you on the next episode. Thank you guys for joining us.
Thank you so much, Bobby.